Where has he been? Is he alive? Is he ever coming back? I am back, and in this video we're going to be doing the 2020 new SPEC Pure Maths Paper 1. And at the start I'll put a place where you can vote on which exam you would like me to do an exam hack series for next. You would have seen my exam hack series for this paper, and if you've taken that, I'm hoping you would have found that extremely useful. So we're going to vote on which one I'm going to do next, because they take a long time to get through. So I'll put that at the start. The first thing to mention here is that in the 2020 to 2022 syllabus, there's been some updates. And in this new SPEC exam, there is questions on each of those updates. So let's just have a look at the updates. And basically what they've done is they've removed a few things and they've added a few things. Not like something crazy, like it's completely different, but they have removed the vector section. It's been moved from paper 1 to Pure Maths paper 3. They've changed this tiny detail in the quadratics, and I thought it'd be useful to just show you this. They've taken the linear solving linear equations out of the inequalities part of the quadratics, and it's just this now. And the things that they've actually added, and the new content in the syllabus is here, and there's a question on each of this new content in the paper we're about to do, so you'll get a good understanding of how they ask questions on this new content. But basically they've added a part to the functions, which is just understanding transformations to functions, where we can move them, stretch them, reflect them, those sort of things, and there's a question on that in this new SPEC paper. There's also, they've added this sort of circle geometry in the coordinate geometry section. There's also a question on this in the paper, and we'll go through that. And they've added this part to the differentiation section in the syllabus from 2020 to 2022. And this is to do with chords and, showing the gradient of a curve at a point using your understanding with chords on that curve, and we'll go through that as well. So now that we've sort of shown you what the changes are, we can start this paper and we can jump right into it. So the first question here is touching on this new part to do with chords and gradients of curves, and it says here there's the following points A, B, C, D, and E, which lie on this curve y equals f of x, and the table below shows the gradients of those chords. And a chord is just so if you had a look at like a curve, let's say this is the point E, and these chords are like going from 2 points on the curve. So that's A, E, and we can do B, C, and D. They're getting closer and closer, which you'll see to do with the gradient. And so let's work out the gradients of these chords to start with. So we know our equation for a gradient is m equals y2 minus y1 over x2 minus x1. So that'll be obviously very helpful here. So for the gradient of CE, the point C is here and the point E is here. So if we want the gradient of CE, let's just expand this, then that will be our y2. So this is obviously our x1, y1, and our x2, y2 in this situation. So our y2 is 9 minus our y1, which is 7.75, and our x2 is 2 minus our x1, which is 1.5. So that's going to give us what, 1.25 divided by 0.5, which equals 2.5. So the gradient of CE is 2.5. And then we can work out the gradient of our chord DE, which equals to our now our x1 and x2 change, x1 and y1 change. So our y2 is again 9 minus our y1, which is 8.79 over 2 minus 1.9. So that gives us 0.21 over 0.1, which equals 2.1. So we've worked out both of those. Now it says state what the values in the table indicate about the value of the gradient of the curve at the point x equals 2. So we know that point E is at x equals 2. So it's asking us what are these chords telling us about the gradient of the curve? Well, we can see as these chords, let's draw this better. So this will give you an understanding of this new part of the syllabus. If this is our point E at x equals 2, and we've got these chords which are getting progressively closer and closer to this point E, like this. You know, we could say this is, you know, this is point A, B, C, and then D would be here and E would be here, and they're getting closer and closer. Well, if we look at this gradient, here at point E, you can see, and this is really badly drawn, but you can see that the chords, as they get closer and closer to this point E, actually get closer and closer to this gradient at E, of the curve at E. So I just want to make that really clear, is that as these chords get closer and closer to the point E along this curve here, they actually get closer and closer to the gradient at E, the gradient of the tangent line. So we can say that actually the gradient at E will be 2, because we can see that these chords are getting closer and closer to 2. And if we wanted to explain that, we could say the gradients of the chords are progressively getting closer and closer to the gradient of the tangent line at E, or at x equals 2, which is the gradient of that line. So I hope that makes a little sense. Okay, so our next question is on functions, and we've seen this style of question before if you look at my exam hack series on the functions question. And here we're given two functions, f of x equals 3x plus 2, and we also given g of x, which equals 4x minus 12. And it wants us to solve this equation. So if we want to solve this equation, let's just find each side of the equation. So what's our inverse of f of x? Well, if we take the 2 over, we get this, and then divide by 3. So we're changing from x relating to f of x, which is what the inverse is. So that means that our inverse of f of x is actually equal to x minus 2 over 3. And if we want to work out g of f of x, which is a composite function, we're subbing f of x into g. So this is 4 f of x minus, we're going to need this, 4 f of x minus 12, which equals, so on here, which equals 4 times 3x plus 2 minus 12, which equals 12x plus 8 minus 12, which equals 12x minus 4. Right. And then we equate these two. So this means we have that x minus 2 over 3, x minus 2 over 3 equals 12x minus 4. And now we can solve this equation. So this gives us x minus 2. We times by 3 here, we get 36x minus 12. And then we can take this over. We get 35x on this side plus 12 equals 10. So we get x equals 3.5, or 7 over 2. So that's your answer there, solving that equation. Okay, again, this has been covered in extensive detail in my exam hack series, but this is the arithmetic progression, and it has the first term equal to 7, so that's our u1 is equal to 7, and it has the nth term, so our un equal to 84, and the u3n term is equal to 245. So find the value of n. Well, we know for a arithmetic progression that we have on our formula sheet, we have this equation here. So that is the un equals u1, which is our first term, plus n minus 1 times d, the difference between successive terms. So we can then find an equation for un and an equation for u3n, and then we can work out n. So we have un equals 7 plus 7, which is our first term, n minus 1 d, which equals 84. So this gives us an equation for one equation, and we can also do our u3n, which equals 7 plus 3n minus 1 d, which equals 245. So that's another equation there, and we can simplify these equations. So let's call this equation 1 and equation 2. Well, for equation 1, we can get that n minus 1d equals, we take the 7 over, we get 84 minus 7, which is 77. And then we can get an equation for d. And the reason that we want to get an equation for d is so we can then substitute it in to our equation 2 and have an equation just with the variable n. And then we can figure out what n is n minus 1. So we have that. And now we look at our equation 2, we take that 7 over, we get 3n minus 1 times d equals 245 minus 7, we get 238. And now if we substitute this into here, we get that 3n minus 1 times 77 over n minus 1 equals 238. So let's simplify this out. This is 77 times 3n minus 1 equals 238 times n minus 1, which then equals, we can use our calculator here, or we can just expand this out. So 77 times 3 is 231n. So this gives us 231n minus 77 equals 238n minus 238. So that gives us 7n equals minus 77 plus 238, 161. So that divided by 7 gives us 23. So we get an n equal to 23. So from that we figured out our n. Boom shakalaka. Okay, question 4. Again, you should be extremely familiar with this style of question because you've seen it. You would have seen it so many times if you've taken my exam hack series. So here we go. We've got a differential. I'm going to rewrite it in exponential form, which is x plus 6 to the negative a half plus 6x to the negative 2. And we also have that f of 3 equals 1. It wants us to find f of x. Well, we simply integrate here. So our f of x is going to equal to the integral of x plus 6 to the negative 1/2 plus 6x to the negative 2 dx, which gives us, we go up by a power, x plus 6 to the 1/2 divided by 1/2 plus 6x to the negative 1 over negative 1. And then we have this plus c, which you shouldn't forget. You can simplify this, which is going to be 2x plus 6 to the 1/2. And this is going to be minus 6 over x. And now we have this, that f of 3 equals 1, so we can calculate our c. So f of 3 equals 1, so we get 1 equals 2 of 3 plus 6, which is 9. Remember, this just means it's square rooted, over 6 over 3 plus c. So we get 2 times 3, which is 6, minus 2 plus c, and this is 4, 1. So c is therefore equal to minus 3. So we get the final result that f of x equals 2 times the square root of x plus 6 minus 6 over x minus 3. So that's our equation of the curve. Boom. Okay, question 5. Now this is again a question on this new material, and this one is to do with the function transformation. So here we're transforming a function or a curve in this case by some sort of a vector, and I'll show you exactly how to do that. So we've got this curve, and it's been translated by 2 in the x direction, remember this is xy, and 0 in the y direction. So find and simplify the equation of the translated curve. So we have this curve here, like this. This is our curve, and it's been translated by 2 in the x direction. So every point on this curve has been moved by 2 in the x direction. So if we find the vertex point, which we can find through completing the square, and we just simply move that vertex point by 2 in the x direction, we can then find the translated curve. So if we have y equals x squared plus 3x plus 4, if we complete the square here, we get x plus 1.5 squared, and that will give us a 3x, and then we'll get a 1.5 times 1.5, which is plus 2.25. So we need to plus 1.75. So that's the completed square. So that means that this vertex point here for this first curve is at the point negative 1.5 and 1.75. Now if we translate that 2 in the x direction, well, that means that this vertex point will simply be 0.5, 1.75. So our new curve is going to be y equals x minus 0.5 squared plus 1.75. And we can expand that out to make it look better, which gives us, this will be x squared minus 0.5, so it's minus x, and plus 0.25 plus 1.75 on the end. So we get a final equation of x squared minus x plus 2. So that's the translated curve when we translate by this vector to 0. And I hope this explanation made a little sense. Now, if we're given, again, this is still to do with that new function function part of the syllabus which has been added. The graph of y equals f of x is transformed to the graph of y equals 3f in brackets minus x. So describe two fully the transformations which occur. Well, we have two transformations here. We have the y of f of x is being changed to y of f of negative x, and we're also getting that y of f of x is getting transformed to y of 3f of x. And let's have a think about what's going on here. Well, for this one, all of our x values in the curve, so let's say if we had a curve here, let's draw a curve. So this is our curve of f of x. If we're to move this to f of negative x, what would that look like? So what does f of negative x look like? Well, all of our x values are changing from positive, which is these are the positive x values, to negative. So what's actually happening here is it's being reflected into by the y-axis, because all of the positive x's are now changing to negative x's. So our new curve will be here, a complete reflection in the y-axis. So that's what happens with the first one. So we can say one of the transformations is y equals f of x is being reflected in the y-axis. And the second transformation here is we've got f of x going to 3 times f of x. Well, you can see that simply what's happening here is that the f of x value, so the y values, are being multiplied by 3. So everything is increasing by a factor of 3. So it's sort of being stretched in the y direction. So you could say that the second transformation is y equals f of x is being stretched by a factor of 3 in the y direction, because all the y points are being multiplied by 3. Okay, hope that makes sense. Question 6, which is just a binomial expansion question, which you should have seen a lot of, hopefully. If you haven't, you know what to do. Take that exam hack series, baby. Okay, so immediately when I see the binomial expansion question, I always get out that formula, you know, the a plus b to the power of n. So we got this formula, a plus b to the power of n equals an plus n1, an minus 1b plus n2, an minus 2b2 plus, you know, that shit keeps going. So just make sure it's correct. Okay, and what does it want to know? Find the coefficients of x squared and x cubed in the expansion of this. Well, our a is 2 and our b is minus x. So, you know, our x squared for our x squared, the term that we're interested in is going to be when our b is squared. So it's when n2 of a to the n, well, this is going to be 6 in this case, right? Our n is 6 and our a is 2. 6 minus 2 is 4 and our b is minus x squared. So if we chuck that in our calculator, 6 combination, it's been a while since I used this. Where's the combination? There it is. Combination 2 times 2 to the power of 4. So this is equal to 240 x squared. So the coefficient is 240 of x squared. And the x cubed, well, this one is going to be 6, 3. So we get 2 to the 3 and minus x to the 3. Again, we chuck this in our calculator. So this is going to be negative 160 x cubed. So that's our coefficient of x cubed. And B, find the coefficient of x cubed in the expansion of this. Well, now we found the coefficients of x squared and x cubed in the expansion of this. And all that's going to happen to contribute to this x cubed term in this entire expression is we're going to get the 3x part timesing in to the x squared part, which is our 240x squared, and also we're going to get the 1 timesing in to the negative 160x squared, x cubed, sorry. So those are the two factors that are going to contribute to our x cubed term in this entire expression. So we're going to get here 3 times 240, which is 720. 720 x cubed minus 160 x cubed. Oh, that's just going to be it's going to be 560 x cubed. So our coefficient of x cubed in this expansion is 560. Okay, let's continue here. Question 7. This is a trigonometry question dealing with these trigonometry functions, and I mean, you should be a whiz at this. We have literally gone through this question so many times, this exact structure in the series, so you should be a whiz at this if you've gone through my hack series. So show the equation 1 plus sine x tan x equals 5 cos x. Show that we can change this into this. Well, we simply need to get everything in terms of cos here, and we can do that by first transforming our tan into sine x over cos x. So we get 1 plus sine squared x over cos x equals 5 cos x. Now we times through by cos, we get cos x plus sine squared x equals 5 cos x. And then we get cos x plus, and this is the equivalent of 1 minus cos squared x. Oh, we times through by cos, so this is a squared. So then we take that cos over, we get 6 cos squared x plus minus cos x, take this over, minus 1 equals 0, which is exactly what we have there. So we've changed, wow. So we've changed this into this. And then, like always, they then ask you to solve the equation. It's exactly the same every single year, even in 2020. They've been doing this question since, like, I've looked back and since like 2014, the same thing every time. So now we need to solve this. Here, 6 cos squared x minus cos x minus 1 equals 0. Yep, 4 between the limits of 0 degrees and 180 degrees. Well, we can simply make a variable substitution, and we can say u is cos of x, so that gives us 6u squared minus u minus 1, which is something we're a lot more comfortable with solving. We can use our quadratic formula. This is minus b, which is plus 1 plus or minus the square root of b squared, which is 1 minus 4 minus 1, 4a, which is 6, c, which is minus 1, all over 2a, and this simply equals 1 plus or minus, and this is 1 plus 24, which is the square root of 25, over 12. So therefore we get u equals 1 plus or minus 5 over 12. So we get two solutions. We get u equals 1 plus 5 over 12, which is 6 over 12, which equals 1/2, or we get u equals 1 minus 5, which is minus 4 over 12, which is equal to minus 1/3. And because our u equals cos of x, we get cos of x equals 1/2, or cos of x equals minus 1/3. And then we chuck those in our calculator. So we get 1/2. So this gives us x equals 60 degrees, and x equals 109.5 degrees. And just to make sure that's all the solutions that we need, well, if we look at the cos graph, which looks like this, this is 180 here. So between 0 and 180, if this is when cos of x equals 1/2, you can see here is our 60, and when it's minus 1/3, right here will be our 109.5. So that's the only two solutions. If it was between 0 and 360, obviously there'd be two more solutions, but it's not. So these are our solutions. X equals 60 degrees and 109.5 degrees. Question 8, which is a differentiation question. So we've got this curve here, our y equals, and again immediately I change it into exponential form, which is this. So we bring it up and it becomes -1 because we bring this up, this whole expression. So then we are going to differentiating this, and this is simply 12 times, we go up, we times down by the power, which is -1, and then we go to x, and then we go down a power, so this becomes -2, and then we times by this differentiator, which is also -2, and that comes from the chain rule. So this is -12 times -2, which is 24. So this is equal to 24 over 3 minus 2x squared. So dy by dx. And again, we've seen these a bunch of times. This exact style of question. A point moves along the curve, and it moves. So the point passes through A. As the point passes through A, the x-coordinate is increasing at a rate of 0.15 units per second. So our dx by dt at point A is equal to 0.15. And then also our dy by dt at the point A is equal to 0.4. So now we've got to find the possible x-coordinates of A. Well, we know, and this is this curve, the same curve as before, we know from the chain rule that our dy by dx, so the gradient of the curve at A, is equal to dy by dt, and this is just the chain rule, at A times dt by dx at A. And from that we'll be able to figure out what the x-coordinates of A are, because this is what the x-coordinates, this is what the gradient of the curve is at the point A. So we can plug this in here. We get 24 over 3 minus 2 x add a squared equals this, which is 0.4, times this, which is 1 over this, because dt by dx equals 1 over dx by dt. So 1 divided by 0.5, 0.15. So we plug that into our calculator. This gives us 8 over 3 here. And 24 over 3 minus xa, 2xa squared. Okay, so then we can just figure this out. So we get 3 times 24, which is 72, equals 8 times 3 minus 2x of a squared. So then we get 3 minus 2x squared equals 9. We square root both sides, we get 3 minus 2x of a equals plus or minus 3. So we have two solutions here, where 3 minus 2x of a equals 3, positive 3, or we can have 3 minus 2 of a equals negative 3. So just work this out, we get minus 2x of a equals 0, so we get x of a equals 0. It's one solution. You also get minus 2x of a equals minus 6, so you get x of a equals 3. So those are our two solutions. So those are the two possible x coordinates of a for this specific scenario. Let's keep going. Question 9. The diagram shows, and I'm pretty sure I might have seen this one before, this exact question looks exactly the same, but the diagram shows a circle with center A and radius R. So we've got this weird ass diagram of circles, and we have to show that the radius of the larger circle is equal to r square root of 2. Well, that's pretty easy. So we can say, you know, this BC length here, this BC length here is big R, and this is length R. BA is length R as well. So that means that R squared is equal to R, small r squared plus R squared, which equals to 2R squared. So R would equal to the square root of this, 2R squared, which equals to R square root 2. So we proved there that big R is equal to small r times square root 2. Cool, so find the area of the shaded region in terms of R. So the area of this shaded region, well, we can think of it like this. We know that the area of this half of a circle, so the area of CDE, so the half circle here, so let's call it, let's just call that area 1 of this half circle is going to be half of pi r squared, right? So that's the area of this half circle, like all of this here. If we minus the area of this segment here, so we can call that the area of the segment, seg, which we need to figure out. So we can say that the area of the shaded region is the area 1 of this half circle minus the area of the segment. Okay, the area of this half circle minus the area of the segment will give us the shaded region here. Cool. So let's work out the area of the segment. So to find the area of the segment, we know that the area of a sector, of this sector here, the area of the sector is going to equal to, from our equation sheet, which is here, area of the sector of a circle in radians, is equal to half, and in this case it's big R, R squared theta, where this is theta. So what is theta? Well, we can work out theta here, because this ACB triangle here, this is going to be theta over 2, right? This angle here is theta over 2, and this length is R, and this length is R, so we can say that tan of theta over 2 equals R over R, which is 1. So to work out theta, all we have to do is we have to figure out this equation, which is just from this triangle here. So I'm just trying to work out theta so I can work out the area of the sector, and from the area of the sector I can then work out the area of the segment by minusing off this big triangle, and from the area of the segment I can then find the area of the shaded region. It's a few steps, that's why it's 6 marks. So if we plug this into our calculator, get shift tan of 1 gives us 45 degrees, which is times 2, so we get theta over 2 equals 45 degrees, therefore theta equals 90, which equals pi over 2. So we have our theta, so therefore the area of the sector equals half R squared, which is this, R square root of 2 squared times theta. So we can simplify that. We get the area of the sector equals, or we get pi over 4 R squared here times 2. So that's going to make this over 2. So we have the area of the sector. Now if we want to find the area of the segment, we have to minus the area of this. We know this is 90. We have to minus the area of this triangle here. So we call that the area of the triangle. And the area of a triangle, a right angle triangle, is half base. And the base here is R times height, which is also R. You see that? Half base times height. So this is half R times R, and base times height, which is half R squared, which is equal to half R square root 2 squared, which is equal to half times R squared 2. Those 2's will cancel, so this is R squared. So the area of the triangle is R squared. Therefore, the area of our segment is equal to the area of our sector minus the area of our triangle, which equals the area of the sector is this, minus R squared. Okay? Which is important. And now finally, we can figure out the area of the shaded region, because the area of the shaded region is this area of the half circle minus the area of the segment. So finally, the area of our shaded region is the area of the half circle, which is half pi R squared, minus the area of the segment, which is pi, which is a half pi R squared minus R squared. So these will cancel and you'll get minus minus R squared, so the area of the shaded region is just simply R squared. Ooh, that was a long one. But I hope that made sense. Like, the first thing I did is I made sure I knew what I was trying to get. I was trying to get find the area of the shaded region, and I figured out what I needed. I needed these two things, and then I just individually figured out how do I get, obviously this one was very easy, just half of the area of a circle, but the area of the segment, how would I get that? Oh, I get that by finding the area of the sector and minusing this big triangle. You know, just break it down. Okay, question 10. Okay, so this is part of the new things that have been added, and this is to do with the circle geometry, and this is the most important part here, the general form of an equation of a circle. So let's just write that down. Oh. So the general form is x minus a squared plus y minus b squared equals r squared. I'm pretty sure that's what it was. Wait, where am I looking? Here. Which they don't give you, so I'm guessing you'll have to remember that. Or just understand it. And I would go away and understand this. And the center is at AB. So if you get it in this form, AB is the center of your circle. So the coordinate of the center of the circle. So it says state the coordinates of C, and C is the center of this circle. So we're given x squared plus y squared plus 4x minus 2y, let's say equals 20. And so the objective here is to simply transform this into this form. And to do that, we have to just complete the squares. So if we put this like this, we put the x's together, plus 4x plus y squared minus 2y equals 20. Well, if we complete the square here, we can say this x squared plus 4x is the same as minus 4. Those two are equivalent. And this is equivalent to y minus 1 squared, and then we're going to get minus 1, which equals 20. So we simplify that out, we get, so we're taking those over, so this is minus 5, take it over, it gives us 25. So the center of our circle, so you could say this is like minus plus 2, you know, no. What am I saying? This is plus 2. So the center of our circle will be at minus 2. So you just change the signs here. Minus 2 and 1. And if you want to figure, so this is the center C. If you want to understand why that is, you should go away and look at these circles and plug in different values for A and B and see how it shifts the circle around. So you can see that this has shifted the center of the circle. So this one has a center. So the general form of a circle, I can just go through it really quick. The general form of a circle is x squared when a and b are 0 plus y squared equals r squared, which gives you a circle with a center, and this is r, so the length r. And the center is at 0, 0. And when you change these a and b values, it shifts the center of this circle. So like this, so like for example, this one will be shifted. This is minus 2 in the x, and then plus 1. So this would be 1 minus 2, and the circle would be here. So you should play around with that so you can understand what that is, because it's a new thing. It is given that the midpoint D of AB has the coordinate, passes through the points AB. So AB exists on the circle, say here. So this is the equation of your circle. So this is your y. Let's just get a picture of what's going on here. X squared plus y squared plus 4x minus 2y minus 20. So that's that. And it says that the midpoint D of AB, So you've got this line AB and the midpoint D of AB. This is the center C. So this is D, which is at 1.5, 1.5. So find the equation of AB, given your answer in the form of y equals mx plus c. Well, simply the thing that you need to understand here is that, so this is the center, any chord, this is a chord connecting 2 points on the circle. Any chord, the perpendicular bisector of that chord always passes through the center of the circle. So this is the chord, this is the perpendicular bisector, PB, the perpendicular bisector, and this is the chord. And there's a theorem in mathematics which says that any chord on a circle, the perpendicular bisector of that chord will always pass through C, the center, will always pass through the center of that circle. And that's something you can take as me just telling you, or you can go away and figure out why this is and figure out if this is true. I would say don't believe me. Go and figure out if this is actually true. But that's the key information to help you solve this here, because then we can find, if we have point C, which we know is at -2, 1, and we have point D, which is at 1.5, 1.5, then we can find the gradient of this line CD. So m of CD equals y1, 1 minus y2 over -2 x, no, sorry, y2, sorry, y1.5 minus y1, which is 1, over x2, which is 1.5 minus 2, which equals 0.5 divided by, this is minus, so that's going to be a plus, 3.5, which is 0.5 divided by 3.5 is 1/7. So the gradient of the line CD is 1/7. And as that line is perpendicular to AB, therefore the gradient of AB is equal to the negative reciprocal of that. So we have the point D, which lies on the line AB, and we have the gradient of that line, so we can then find the equation of that line through this. So we get y minus 1.5 equals -7 times x minus 1.5. So y minus 1.5 equals -7x minus 7 times minus 1.5 is 10.5. So we get y equals -7x plus 12. That's the equation of the line, AB. So the key information there was this, understanding the relationship between the chord and the perpendicular bisector of the chord. And that's new information which they've added. So now find by calculation the x coordinates of A and B. Well, that's simply going to be the intersection between the equation of the circle and the equation of our line, which we found. So the equation of our line is -7x plus 12, and the equation of our circle is y equals x squared plus y squared plus 4x minus 2y minus 20 plus 4x minus 2y minus 20. So let's just substitute this into, that makes no sense, sorry. This equals 0. That was a mistake. So this equals 0. So we substitute this y into here, and we get x squared plus -7x plus 12 squared plus 4x minus 2 second x plus 12 minus 20 equals 0. Let's expand all this out. So we get plus 49x squared. 7 times 12 minus 168x plus 4x plus 14x minus 24 minus 20 equals 0. Okay, that gives us 50x squared. Squared minus 150x. It's looking pretty promising. Plus, well, that'll be 100 equals 0. Okay, we can divide through by 50 here to make it look really good. And that's going to be x minus 1 and x minus 2. So our coordinates, x coordinates of a and b are x equals 1 and x equals 2. I hope that question made sense. I know I say that after every question, but that is my hope for you, that it does make sense. Okay, let's continue here. We've got a function question. So we've got a function defined for all the real numbers. They didn't leave a single real number out. Every single real number. We have this, where a and b are constants. If a and b are 6 and -8, find the range of f. So we have f of x equals x squared plus 6x minus 8. Well, as this is a parabola, we want to find this vertex point to see what the lowest point f of x goes to, and it will be defined for being greater than that. So we do that by simply completing that square. X plus 3 squared, and that gives us a plus 9, so then we need to minus, to get minus 8, we need to minus, what do we need to minus? Minus 17, so we need to minus 17. So therefore, this is at the point -3 minus 17. So the lowest point this function goes to is -17. So our range of our function is always going to be greater than or equal to -17, because it's not defined below that. That's the vertex point. Okay. Now, it is given that instead that a is equal to 5 and the roots of the equation are k and minus 2k. Find the values of b and k. Okay, so now our f of x equals x squared. No, it equals 0 now. So x squared plus 5x plus b equals 0. So that means, if the roots of this, that means that we have x minus k. This would factor to x plus 2k. So that means that x squared plus 5x plus b equals this. Okay? Because these are the roots. That means that this equals this. So let's expand that out, and we'll be able to find these terms. So we get x squared. We get plus 2k minus k, which is plus kx, and then minus 2k squared. Okay, so that means that our 5 is equal to k, so that means our k equals 5, because now they're of the same form. And then our minus 2k squared equals b squared, equals b here and here, and we know k is 5, so we get minus 2 times 5 squared equals b, so then b equals -50. Okay, Now we move on to C, which again touches on, this is great to do this new spec paper because we get a lot of questions on these new areas which they've added into the syllabus. So this again touches on transformations, and let's have a read first. This is going to be a more mathematical one, so we don't really have to visualize what's happening to this function. But so show if the equation has no real roots, which immediately we're thinking that means that our discriminant is going to be, if it has no real roots, it's going to be less than 0. And we know that our f of x from above is x squared plus ax plus b. So if this has no real roots, this equation here, we have to show this is true. So let's figure this out first. Well, f of x plus a, we just substitute this into x. We get x plus a squared plus a x plus a plus b, and that equals a. So let's simplify this out. So we expand this out, we get x squared plus 2ax plus a squared plus ax plus a squared plus b, and then if we take this over, minus a equals 0. So we get x squared plus 2a, and a is 3ax plus 2a squared plus b minus a. So here we have our, now this is 1, so that means our a in this case for working out our discriminant, because this is saying that this equation here has no real roots, which means this is true. So our a is 1, our b is equal to 3a, and our c is equal to this. So we get b squared, which is 3a squared minus 4, 1c. And if all goes well, this should become this. So this is 9a squared minus minus 8a squared plus 4b minus 4a is less than 0. So that's a squared plus 4b minus 4a is less than 0. We then take these over to get it in this form. We get a squared is less than 4a minus 4b. Oh, we've done something wrong here. So you can see where I've gone wrong is when we times in by the negative, I forgot to change these signs. So this becomes a negative b and a positive a. So we get a squared is less, well, is less than 4b plus 4a is less than 0, and then we get a squared is less than 4b minus 4a, which gives us the final answer of a squared is less than 4b minus a, which is exactly what they had above. So when this equation has no real roots, this is valid. And 12, which I think is the final one. Yep, this is the final question. So question 12, which is, looks like it's going to be an integration question. So let's do it. The diagram shows the curve y equals this. The minimum point of the curve has the coordinates a0, and the x coordinate of the maximum point is b, where a and b are constant. State the value of a. Well, a occurs when x equals 0. So if we have this curve here, oh no, a occurs when y equals 0. So when we have this curve here, we get 0 equals x x minus 2 squared. Well, it can't be this one, because this is when y equals 0, you know, we get this origin, so it's not when x equals 0. So our solutions are x equals 0 and x equals 2. But clearly it's not this one, so our a equals 2. Calculate the value of b. Okay. Well, b occurs at a maximum point. So if we write this out, y equals x minus 2 squared. Let's expand this out so we can differentiate this. So we get x times x squared minus 4x plus 4. This gives us x cubed minus 4x squared plus 4x. So that's our y. Now the reason why I'm differentiating it is because I know that b occurs at a stationary point. So we find dy by dx equals 3x squared minus 4 minus 8x plus 4. And this is a stationary point when our differential equals 0. So and this is going to occur at these 2 points. So we know one of the solutions to this is when x equals 2. So when x equals 2, and you can check that, you know, if you 2 squared, you know, you're going to get 12 minus 16 plus 4, which is 0. So that's going to be one of your solutions. So you know that x minus 2 is a solution. So then you can factor the next one, which will be 3x minus 2. Right, we get minus 6. Okay, so that means that your b is going to occur when 3x minus 2 equals 0. And that is when x equals 2 over 3. So our b is 2 over 3. So I hope my logic made sense there. I was just saying that, you know, if we differentiate this, we can find the solutions to this equation, and there's going to be 2 solutions. One of them would have been a, which is at x equals 2, and another one would have been b. So we just figured that out. Okay, C, find the area of the shaded region. Well, this is simple integration. So we get y. And the reason I put it in this form is so I can differentiate and integrate this very easily. X cubed plus minus 4x squared plus, oh wait, that's minus 4x squared plus 4x. So we want to integrate this curve between 0 and 2. So this is at x equals 2. So we go, the area of the shaded region is equal to the integral between 2 and 0 of this bad boy. Which gives us x4 over 4 minus 4x3 over 3 plus 4x squared over 2, which is simply 2x squared between 2 and 0. Well, we just have to plug 2 into this, because 0 will just be 0. So we get 2 to the power 4 divided by 4 gives us 4 minus 32 over 3 plus 8 minus 0, and that just equals plus 8 plus 4 is 4 over 3. So the area of our shaded region is 4 over 3. And finally, the last question here. is the gradient dy dx of the curve has a minimum value m. Calculate the value of m. So dy by dx, which equals where is it? Yeah, 3x squared minus 8x plus 4. 3x squared minus 8x plus 4. This curve, which is a parabola, has a minimum at m. So to find this minimum, we can simply, like if you were to find the minimum of a normal curve like y equals x squared, you're like, okay, where's this minimum? Well, we'd find dy by dx, and then we'd get 2x and we set that to 0 because we know that the minimum point will be a stationary point. So we just do the same here. We take the derivative of this, so we take the derivative, which would be the second derivative, which equals, let's call, oh no, it doesn't matter, second derivative, which will be 6x minus 8, and we set that equal to 0, and that'll give us this point here, the vertex point. So we get 6x equals 8, and x equals 8 over 6, which is 4 over 3. So the x coordinate of the minimum, but it says the curve, so this is, so that means that m, the minimum of this, is when x equals 4 over 3. So we simply plug this into here. 3 times 4 over 3 minus 8, 4 over 3 plus 4, and we'll get, plug that in, we get minus 4 over 3. Bit of switcheroonie there. So that's the minimum of this curve, which occurs at x equals 4 over 3. Okay, and that's the end of this new SPEC paper, which covers lots of questions to do with these, which are included in the syllabus updates. So vote on what exam hack series I should do next, and if it gets enough votes, I will do that exam. And yeah, stick around. We're going to try and do as many exams as possible, and really the goal of this channel is to show you how these exams can be very easily predicted through their structure, and very easily, when they're very easily predicted, it's very easy to sit them, and we just do that by analysis. So when you take one of these exam hack series, you'll get such a deep understanding of the structure of the exam, and from that understanding you'll be able to sit, pass, and do extremely well in these exams like no problem. So that's the general goal of this channel, and if you're down with that goal and you want your exam to be hacked next, subscribe, vote, and you know what, drop me a like. Do it, why not? Alright, see you soon. Bye.